Okay, one last density calculation. All right. If you recall this pill bottle we measured, we hopefully went ahead and computed the volume of the space inside this bottle. All right. If we were to fill up that space with water, then we know the volume of the water that's in there. Okay. So what we're going to do real quick is do a density calculation for water. All right. To do density, all you need is a mass and a volume of some sample of water. If I fill that bottle with water, I'll know its volume. Whatever you computed, all right, when you took pi r squared h for that pill bottle, all right, that's the volume of anything that fills up that pill bottle. So we're going to take this pill bottle and fill it with water, all right, and then we're going to go ahead and measure its mass. However, if I put this pill bottle down onto the balance filled with water and measure its mass, I'm not measuring just the mass of the water. I would be measuring the mass of the water along with the plastic of the pill bottle. So what I need to do before we go ahead and fill this with water is get a mass of this pill bottle with nothing in it. All right. So the first thing I'm going to do, take everything off the balance, zero it out. All right. Read 0. And then I'm going to stick it on there and write this down. If I could find my pencil. All right. So light's in the way. 26.15 grams. 26.15 grams is the mass. I'm writing over here. Mass of empty pill bottle. Okay. Let me erase that. And in a minute, I'm going to put some water in there, and I'm going to measure its mass again. And I would label that mass of pill bottle with water. Okay. So let me just stick this up here real quick. And I am going to take this pill bottle and fill her on up with water. Now I'm going to try to fill it as much as I can to the tippy top. All right. It is almost to the point of overflowing. Now I just have to get it back onto the balance without spilling any. All right. As you can see, maybe you can see, the water is just to the tippy top. I might be able to get a couple more drops in there, but I'm going to leave it as is. Now I go here and I copy down this data. The mass of that bottle now filled with water is 238.16 grams. Right, 238.16 grams. So what I need to figure out is, what is the mass of just the water? All right. How would I get that? If you said take that reading and subtract that reading from it, that would be absolutely correct. So when you get this minus this, that will be your mass of water. And so then what do you do with that? Well, what you do with that is plug into the density formula, because I want you to compute the density of water. And it was that sample that we're going to use. What was the mass of that water? That's down there. What's the volume of that water? Well, the volume of the water is the volume of the container it's in. Did we compute the volume of that plastic container? Well, we sure should have. Go back into your calculations and look. Stick both those numbers in there. Get an answer. All right. Now, during the course of studying in chemistry class, I don't have you memorize many numbers, but this is certainly one of them. What is the density of water? Well, you should get something close to 1.0. 1.0 gram per cubic centimeter. All right. The density of water is equal to 1, the density of liquid water. 1 gram per cubic centimeter, or this could also be written as 1.0 gram per milliliter. Either or. All right. This is what I'm hoping you'll get when you take your mass, or the mass that we measured here, divided by whatever the volume of this container is. All right. Go back and look at the calculation. Put those two numbers in there, and let's hope we get 1 or something darn close to it. But give that a whirl, see what you get.